Openclaw is the most powerful software and tool I've ever used so far with no exaggeration, but its high token usage and cost make many people back off, or they cannot unlock its full potential. Today, we'll introduce four methods to cut the cost by more than 10 times without sacrificing the performance at all, so you can get token freedom and everybody can enjoy using Openclaw. Alright, no more small talk, let's get started. Before we talk about method, we first need to say what is actually consuming our tokens. In fact, in every round of conversation with a large language model, what we send to it in the end is not only our questions, but a whole work package. It includes, first, a system prompt, second, some files in the workspace, for example, agent, user, tools memory, these markdown files. Third, our chat history. When we talk to our AI in Telegram or Discord, there's a snowball effect where more and more history get involved. Fourth, some tools output, like the main task from a web page is fetched. Fifth, and only the fifth part is a question we ask it in this round. So why is it expensive? Because in every round we have to give the model the manual again. Just like a new employee arrives in our company, every time we talk to him, we need to read the employee's handbook, the company's rules, the job SOP all over again. And only then we ask our real questions. Of course, it becomes expensive. So how do we save tokens in one sentence? Make the input of each round shorter, cleaner, and more controllable. First, let's look at our first method, QMD. In the traditional way, we have to stuff our entire node and materials into the model like force feeding. But with QMD, we can build index locally for markdown knowledge base. So when we ask question, it only returns the top few most relevant snippets and phrases. And only these snippets are injected into Openclaw. In other words, the model no longer reads a whole library. It only reads a few paragraphs that match. So how does it work? How is index built? There are two steps. First step, update the index. It finds which files were added, changed, or deleted. Then it updates the trunk path and metadata. It's like updating the table of contents. Step 2, update vectors. It only creates vectors from new or changed trunks and project them into the vector database. During the semantic search, it calculates similarity between these vectors and pull out the vectors related to the question. Key point here is both of steps runs locally and they do not consume cloud tokens. So QMD turns the cloud token cost, which API cost, of reading all files and information into a local indexing cost. So how we can install QMD? It's actually quite easy. The easiest way is to let Openclaw install for you. But if you want to install it manually, there are three steps. First, run these commands in the terminal to install QMD. Then, go to the Openclaw.json file and make sure your memory section looks like this. Then restart the gateway, and that's it. One more thing worth mentioning is that QMD actually allows you to control your budget precisely through three parameters. Still, in the Openclaw.json file, under limit, you can see these three parameters, or if they don't exist, just you can add them. Max result, how many snippets can be injected at most. Second, max snippet charts, how long each snippet is allowed to be. Third, max injected charts, the maximum total injected length per round. This is the overall budget valve. Now let's introduce the second method, run heartbeats with local model. First, what is a heartbeat? Heartbeat is Openclaw's timed wake-up behavior. It wakes the agent based on the frequency you configured and let it run a heartbeat checklist. It is not checking whether your process is alive. It is a trigger action. It first reads the checklist in the heartbeat.md file, then decide whether the maintenance is needed, whether the reminders are needed, or whether it needs to run some tests. If nothing is needed, it just outputs a very short confirmation. If something is needed, it executes the task. In one sentence, a heartbeat itself is one full agent round. It is very powerful. It can have many different uses. For example, it can act like a supervisor. If you have worked with Openclaw, it's easy to notice this, like sometimes you give it a very long-term task and go. It promises to finish it, but often after doing one step, it stops. It may not keep pushing forward. At this time, you can use heartbeats. Just poke it regularly, for example, every 30 minutes to trigger the agent and ask, do you finish the task? Before you finish, you are not allowed to stop. This keeps our agent Openclaw, consistent and help ensure it completes long-term tasks. But why heartbeat can cost a lot of tokens? Because each heartbeat input usually includes the system prompt, workspace file inputs, especially membrane.md, which can get very large, possibly the chat history, the heartbeat prompt and checklist for this run. So even if the output is very short, maybe like okay, no problem, but input can become very large. Also, let's do the math. If the heartbeat frequency is once every 30 minutes, then in 1 month, that's 1,440 heartbeats. That means 1,440 extra automatically built agent runs. So how can we reduce the heartbeat cost? Besides the usual method of including the interval, the most fundamental way is to use a local model, a small local model, to do the heartbeat for this low intelligence task. Heartbeat is only used to trigger, not used to execute any task. So if you want to use a local model, you need to also download the Llama and then choose a suitable local model based on your computer's memory. For example, different size of chain-one models here. Then you can tell Openclaw, use a local small model to handle the heartbeat trigger task. Now we come to the third method, which is also the simplest. Try to use subscriptions as much as possible instead of paying by API usage. One thing to note though, many providers does not allow do this. For example, Anthropic, their subscriptions strictly forbid being used inside Openclaw. But OpenAI just acquired Openclaw, so for now it's still open and allowed. If you want the extreme stability, you choose using API usage instead of subscriptions, then you need to be careful. If you use the latest model, whether it's Anthropic, Gemini, OpenAI, your bill will grow multiple times. I already said in the previous video, I use Minimax API usage for $30 a day. If you convert that into Anthropic pricing, with the latest Opus 4.6, it could cost me $500 per day. So you really need to pay attention to that. Now let's look at the fourth method. This is a customized method and different people might do it differently. For your own Openclaw, ask it to generate a cost health check report. No fixed format needed, just ask it for the top driver list, maybe in a percentage, to say which task borrowed most money and where the highest consumption comes from. Also found what is unreasonable, because when you just first start using Openclaw, I can promise you there are always many tasks that are not reasonable. For example, a light task carries a huge context, or a task should be event triggered, like if A then B, but it is built as pooling instead, like checking every 10 minutes whether A is triggered. There are many different unreasonable parts that can be optimized. In one sentence, high cost is not always necessary cost. A lot of waste come from process and configurations. We need to optimize it based on our own use case and task. So after you found problems, how do you optimize it? You can think from two different angles, process and models. From the process side, can some polling tests be changed into the event trigger? Does it fit the conditions? Again, the QMD method we talked about is also a great way to reduce the context injection. From the model side, for some light tests, can we use cheaper model or small model instead? And the local model heartbeat we mentioned is also a very good method. Finally, based on the test list Openclaw gave it to you, discuss with it which tasks can be optimized to reduce cost. Now let's summarize 4 methods to greatly reduce cost. First, use QMD to greatly reduce context injection. Second, use a local model for heartbeat. Third, use subscriptions as much as possible, not pay by API usage. Fourth, ask your own Openclaw to list a token-consuming task from high to low, then discuss optimization possibility and how to optimize. Alright, that's all for today's video. Do not forget to follow. See you next time.